Hello students, in this video we are going to start here another new method of solving differential equation of higher order. So as we have already seen the differential equation of higher order and under the topic we have seen how to solve a homogeneous equation and non-homogeneous equations with a particular integral. That means your f of x function in the format of exponential, or it's supposed to be in trigonometry in sine or cos term, or it's supposed to be a polynomial cases we have seen. Okay, so in this video what we are going to see in the new method, the method is called as an Cauchy's differential equations. Here it should be under the non-homogeneous, but the differential equations coefficients must be in terms of a variable. So before we have seen all the methods which you have a only homogeneous or non-homogeneous of all the three type. It is all the method has been carried only with your differential operator wherever it is used in d power n by dx power n or d square by dx square term d by dx. All the places the coefficient must be 1. Here 1 or the number it must be, right? So here we are going to see the coefficient in terms of your variable. So in this topic under the variable coefficient we have a two method. So in this video we are going to see the first method is called Cauchy's differential equations. Okay, so in this what you are having it, the variable coefficient is x power n format. So if it is there in the x power n format, that is x squared into d squared y by dx squared term, then x into dy by dx. In that cases, by default you are supposed to assume it you are going to convert in terms of a constant coefficient. For that reason we are considering t is equal to log x. So we are introducing the new variable t is equal to log x. Take exponential, you will get x. What is your x? X is equal to e power t. Okay, so this we are assuming it for x is equal to e power t. Now you will be having your derivative, how it will change. X into y dash to be replaced by dy, and x squared into y double dash to be replaced by d into d minus 1 into y. X cube into y triple dash is to be replaced by d into d minus 1 into d minus 2 into y, etc. Okay, and here also the solution as complementary functions plus particular integral will give your complete solutions, and it should be in terms of t. If you are having it, you are going to replace again in terms of x. Okay, so that is your complete solutions. It's clear the method. Okay, so let me go with one example to understand. Okay, so you see the question. The question will be solved x squared into d squared y by dx squared minus 3x into dy by dx plus 4y, which is equal to 1 plus x the whole square. You can see the question. Suppose this x squared and here it is an x is not there. We can solve it easily. In the left side will be in complementary function, right side you can expand a plus b the whole square, you can reach your polynomial format, right? So now you can see it is there the variable coefficient. First I am going to convert in terms of constant coefficient before I am into the solving part, isn't it? So it is under the x format, that means x squared into d square format is there. So I should use this under for Cauchy's method, right? So the Cauchy's differentiation method, what you have to do, assume it as per the steps what we have seen. You can assume it t is equal to log x, na, that is x is equal to e power t. Same format you can do, assume it, and immediately you have this x into y dash to be replaced by dy, then x squared into y double dash. It has come only from here which you have assumed it. Only from there only we can write it. So it's not like that. It's directly it has come. Okay, so you can take the differentiation. Dy is nothing but dy by dx, na. So this all the expansion it's come from what you have taking a substitution. You can, it can be replaced like that. Okay, so as you need only the method how it is work, so it's not required how it has come here, dy d into d minus 1 and all. Just you remember it is dx squared into y dash is equal to d into d minus 1 into y, and d is equal to d by what is that, d by d. Instead of dy here you have d by dt, because we have assumed it in terms of t, right? So now you can go with substitution to the equation. First one, x square into y double dash to be replaced by d into d minus 1. Y I have written as a common, and the next one minus 3 into x into dy by dx. So x into y dash to be replaced by dy. So I will get only minus 3d plus 4 into y is equal to right side also is supposed to be replaced. What is that? 1 plus I have x, right? So 1 plus x is nothing but e power t na. So replace e power t the whole square. So now you can do the simplification of this equation. You will get d square minus 4d plus 4 into y, which is equal to expand a plus b the whole square. It will become 1 plus e power 2t plus 2 e power t, isn't it? So now it's become a normal. What is that? It is a higher order differential equation with constant coefficient. So I can go with algebraic equation. You replace m square minus 4m plus 4 is equal to 0 by replacing d is equal to m. So you will get the factorization method. M will be 2 comma 2, isn't it? So now you can go with a which case it will go, it will be a real and equal. So it will go for case 2. So c1 plus c2 into t. Here t is your variable because we have converted x expressed in terms of t. So instead of x we are supposed to use for t, isn't it? c1 plus c2 t into e power 2t. Now you can go with a particular integral. So particular integral, it has been taken with 3 terms because 1 plus 2 e power t plus e power 2t by d square minus 4d plus 4. So 1 by term 2 e power t by d square minus 4d plus 4, then e power 2t by d square minus 4d plus 4. So it will become 3 particular integral. You can do it in attested, or if you need you can do it separately with particular integral 1, 2, 3. So it has taken here. I am done with 3 particular integral. The first one replaced by constant. So what you have to do? You have to replace e to the power of 0x because it's supposed to be 1, right? E power of 0x will go for 1. So you have only the existing method because remaining 2 we can't use it. Trigonometry and for what is it? Polynomial equation. For that reason I have chosen for exponential. What is it? As per exponential method, d supposed to be replaced by a is 0 here. So 0, 0. So I will get 1 by 4. It's clear now? Now go with your second particular integral. So what is your second particular integral? It is 2 into e power t by d square minus 4d plus 4. So here also it is e power ax formula. D to be replaced by a value is 1 here. Okay. So it will go 1 square minus 4 plus 4. It will be 2 into e power t because plus 4 minus 4 will get cancelled. Go with the third particular integral. So it is e power 2t by, it is again it is for which method? It will be in e power 80. D is equal to 2. You can replace. It is a 4 minus 4 into 2 will be 8 plus 4. So plus 8 and minus 8, denominator is going to 0. What you have to do? If it is denominator is going to 0, I have to use it. What is that? You have to use a differentiation. So take a differentiation part to the, what you have to do? Take a differentiation part. So I can use it like multiple with a independent variable to the numerator. I'll get e power 2t by denominator. I can do the differentiation. So 2d I will get, then minus 4 I will get. So again you can replace. What will happen? You can replace for d is equal to 2. Denominator will go for 0. So what you have to do? One more time you can differentiate. It will become a, what is that? D squared, t squared, then you will get only the term of 2. So the answer, that's why has been written t squared into e power 2t by 2. It's clear na? So all the 3 particular integral combine, you will get 1 by 4 plus 2 e power t plus t squared e power 2t by 2. Okay. So that's all. Complete solution you are supposed to write in terms of x again. So complementary function plus particular integral in terms of t has been written. So what is that? T is supposed to be replaced by, t is nothing but log x. E power t is x, e power 2t will become x square. Then again t is log x the whole square and x square plus here it will be 2x plus 1 by 4. This is your complete solutions. It's clear na? Now you can practice with some two questions I have given it. You can able to use the Cauchy's differential equation to solve that, and I have given for answer also. It's not much difficult. It is a direct questions, and one more also is that for the practice. Okay, so kindly practice and verify whether you are getting that answer. Thank you.